My name is Cedric, and in this demo here, we'll be looking into our FSM code that we have, and we're going to be going through on how we will be debugging our given code here, which is an FSM, a finite state machine. And so we're going to be using two types of debugging tools: the ILA, the Integrated Logic Analyzer, and the VIO, the Virtual Input Output. All right, and we'll be using those so we can analyze if depending on our inputs, if we're getting our proper output that we expect, right? And so using these debugging tools, we should be able to see if our hardware program is being fully compatible with our implementing hardware, right? And so I may not be showing the FPGA board because it really, you can't really see the difference, the switching between different states, because we'll be seeing here in this code that the states change so often that just the FPGA board won't do it really any justice. So we'll be using the VIO and the ILA debugging tools. All right. So going through the FSM code here, we would be able to see that we have two types of inputs, right, that are going to be integrated into the FPGA. All right, we have the restart pin, and then we have the pause pin. And these will be switching. You can only flip these two switches. And then we have our clock, as this is a sequential circuit here. And then we have our outputs, which are even, odd, and terminal, right? And then we have we're just claiming our different states here that are going to be 2 bits, which we're going to have our first, second, and third state, right? And then pretty much in here, we're pretty much stating that we're going to be using virtual input and virtual input output wires, right, for restart and pause, right? And we pretty much need to do this when using for the debugging tool, which you're pretty much calling which specific probe you're using for the specific input and for the specific wires that we have here, and then for the specific registers that we have also included here, which is state. Like state needs to be claimed here, but we're pretty much stating the input and output for the virtual input output debugging tool, right? And the same is being said here for the ILA debugging tool, which is being shown here, all right? We're just saying which probe correlates to what's in our specific module here for our FSM, right? And so here we're just claiming here as a restart, which is going to be the restart, which restart is being claimed either from the FPGA pin or from our VIO debugging setup, right? Because we'll be able to see that we're able to make each input either a 1 or 0. We're able to manually change that, and we don't need to touch the FPGA board, which makes the FPGA board a good debugging tool in itself, but we're able to do everything through Verilog here. So, and the same can be said for pause, which again we can do pause either on the FPGA or through Verilog here. We use the VIO debugging tool, right? And so here is where we're pretty much switching through our first, second, and third states, which going through here briefly, we'll see that if restart or pause is being switched, then either or, then we're going to be in the first state, and then if not, then we're going to go to the second state. If in the case neither of these, if this is not true, right? And then if we go into the second state, and if restart is the only one on, then we're gonna go back to our first. And then if pause is the only one that's on in our second state, then we're gonna stay in our second state. And then if state our state oh if neither of these are true, then we're gonna go into the third state. Is what I mean to say, right? And then going on to our last state here, pretty much if restart is 0 and pause is 1, right? So pause is the only one that's up, right? So if pause is 1, right, and the restart is 0, right? Then we're gonna go to the third state. We're gonna stay in that third state, right? And then if that is not true, then we're going to go back to first state, right? And then of course we're setting our default as first state because it's the first state. And then here we're pretty much signifying our even and odd terms for our output, right? And also a terminal, right? So this is what's basically happening in the general FSM. And again to reiterate, this is our ILA probes and how it's correlating to our inputs and outputs, right? Which is quite significant. And then we have a string file, which is mainly for our FPGA. Like here we are seeing again our clock speed, which is going to be we're going to have a period of 10 nanoseconds. And then these are just referencing to the specific switches that will be for our input, and then our output for like the LEDs, right? So yeah. So as after we do this, then pretty much we would then have to go into VIO, the debugging tool. And we would have to pretty much change certain specifications so that we can use these virtual input and outputs, right? And this is pretty much what I have here, which will be good enough to test our FSM, right? And then to just look over the ILA too. See here now we have 6 probes, and then we have our clock, and then we pretty much have this for probe 2 here, where it's going to be 2 bits, right? So, looking over, now that we already have that, so now we're going to go into the process of debugging, alright? And so since now that we already have our VIO and our ILA, arranging like the probes. Now we're gonna just generate the bit stream, and if we open our target, program the device. Okay, so there's a couple things that we would have to do here. So we want to be analyzing the changing of states, right? If it's changing appropriately, right? So one of the things that we have to do is set up a trigger, right? And this trigger is going to be for pause, right? And we're basically setting up this trigger when we go from the transitioning from high to low, which is, yes, high to low. So we're doing a high to low transition here, right? So this is when we activate the trigger, and it senses that high to low state for specifically pause, then it's going to then record the state. All right, and so this would be the part of for the ILA, where it observes the trigger, right? And if we look into the VIO debug section, then we can see pause and restart, right? And you know, each state they're just changing so frequently, um, just because that's how the FSM is just built, right? But one of the things that I want to just show how the VIO is operating. So in my FPGA board, right, it's everything's already coded. So if I were to put high for pause, then this is going to just become 1, right? Yeah, so now this just becomes high, and then I can put high for uh, restart. It's going to turn to 1, 2, and then I can put them both low, right? So that's me physically doing it on the FPGA board, all right? And then if I were to raise, I can do it virtually. I can do change the input virtually, and it's going to change the actual pause. So there's like an actual connection from this probe, which controls this one, right? So, and even if I were to make it 0 for pause, it's just not going to affect anything because this virtual um, input, it's already setting an input, right? So there's not gonna be any sort of interference. Um, and the same can be done for here restart here as well. All right, and we can then see that restart then turns into high, and then the changing of states occurred, right? And then if we were to refer back to the FSM code, is that when pause and restart is high, then pretty much we're in our third state here. So this one says if restart, so if restart 0 and then pause. Well, actually, let me see here. Okay, so actually, this is the transitioning here. So where both of them are high here from the second state, when it was transitioning, it was going to this third state. So when they're both high, so it's more referencing this one here, not this one. Um, but looking back into the VIO, if we're gonna be practicing the triggering here, so of course we're triggering pause. So we're gonna trigger pause. So I'm gonna do put on the trigger, right? And when we do that, it's waiting for the trigger, the ILA. And so virtually, I'm gonna change both these inputs to high. They're already high, right? And it's waiting for the pause trigger, right? So we're gonna observe these changing of states, right? So right now it's at state 3, right? I'm gonna put this at 0 and restart 0. Okay, so now I'm gonna change this to 0 here, and then it goes to 1, and then now this is where continuously just change states, um, right? And if we were to look here in the ILA, we wouldn't notice this changing of states. Now, though this is so there's an issue on how this is, right? So it just captures the first state. It basically transitions from the third state, and then it immediately just captures the first state, right? And which it is correct to the logic of the FSM, right? On how it's built. But the major issue here is the time capturing um, for the debugging system. Now, I wasn't able to figure it out, but we were able to see here that if I change it virtually here to 1, then it's going to go to the first state, right? And if I change this one to 1, and this is going to go to the third state, right? And it stays in the third state, right? This is all fine, right? But it's not actually reflecting on here properly, right? So that's my huge issue, and I do believe that this is because like it it might be reading up to here, but potentially the transitioning of states is too quick that the ILA cannot capture it within that like certain time frame. That's what I believe. It gives this green line, which I believe is just like an error. But realistically, it's supposed to be counting down from the first to second and the third, and then continuously change states on however the FSM is programmed, right? So even though it's an issue, um, and it's not translating well into the ILA, we could also just compare it and verify it through here, because this VIO is doing a good it's a good way to check here, where I if I so we know that if they're both high, pause and restart is high. We can just verify here. So uh, if they're both high, pretty much because this one's if one of them is on, right? But if they're both on in this sense, because this is else, then we're gonna stay into this third state. So state turns into 3, so that's why it stays in 3, right? Um, but then if I were to make this to 0, so if pause is 0, so now that means is that pause is 1, restart is high, pause is low. So then checking from the VIO, we would see that it does fit under the third state here. Yeah, it does fit under this third state here, where pause is high, right? So that does fit under. I mean, where restart is high, right, and the other one is low, right? Um, yes, it does. So that one works, right? And then if I were to go restart low, right? So if I were to say this one's low and then this one's high, right? Then this is the first state, right? And if this one's the first state, right? So pause is high. Shoot. So if pause is high, this is supposed to be the first state, right? Here. And pause is high. And pause is high, so it is going to be for the first state. So in this way, we're able to verify with the VIO purely without using the ILA. But the ILA gives us more of a better time frame. But unfortunately, like again, it wasn't cooperating, and I do not know how to use the debug feature as good as I should, as I'm new to it. But I did learn of the debug feature, which I do believe is a big deal, um, because and now that I am aware of the debug feature for both the ILA and VIO, and hopefully continuously to learn other sorts of features for the debugging, it brings a it brings a good outline of what I should be looking for, right? And I'm able to observe, even if it didn't operate properly, I'm able to at least observe why it might have not worked properly. And though I try to fix the debugging itself, the ILA, I wasn't able to figure it out, but I do have a potential solution to the problem, which I believe would be um, to probably expand the time frame. That would probably work, though I don't really know how to do that. Um, but yes, but learning generally the debug feature was quite interesting, and I'd like to learn. I'm interested in learning more about the different operations of debugging.